Hello.
Hello.
Yeah, can you hear me?
Yes.
Okay, which paper have you tried?
2024 10A.
Okay.
Mm-hmm.
Uh, okay, so question number 15 to 25, those are the questions that we have to target.
Yeah.
Tell me which ones you could do, which ones you couldn't do.
Um, I needed help on problem number 17.
Okay, 1 second.
Mm-hmm.
Mm, Okay, so the question says two teams are in a best two out of three playoff. The teams will play at most three games, and the winner of the playoff is the first team to win two games. First game is played on Team A's home field, and remaining games are played on Team B's home field. Team A has a 2 by 3 chance of winning at home. Probability of winning and playing away from home is P. The outcome of the games are independent. The probability that Team A wins the playoff is half. Find P.
Yeah.
Actually, it's very easy. Team A plays the first game at home, and after that, the remaining two games on Team B's home. This you should have done. So, probability of A winning at home is 2 by 3. Probability of A winning away is P.
Yeah.
What are the ways in which A can win the playoff?
Mm, if they win the first two matches, uh, the
Or
second the second two, or the first and the third.
what do you mean second two?
So like, let's say team B wins the first one, but A wins the other two. Yeah. And then ABA. Yeah.
Why have you not been able to do this? This is so easy because we know already first game is played on home and other games are not played at home for A.
Yeah.
What is the
Uh,
probability of this happening?
uh, 1/3.
What is the probability of AA, two wins, first two wins? It's not 1/3.
Oh, 1/4.
How come? Why will be it 1/4?
Because for the first one, you could have either A or B, and the second one, you could have A or B. So,
What are you talking about? Probability of winning is 2/3 at home and winning
oh, so
away is a P.
so then if it's at home, then it's 4/9.
You are not thinking at all. If you don't read the question, how come you'll get the, how are you trying to do the thing without even reading the question carefully? Are both the games played at A's home?
Mm, oh no, just the first one. So then the first one, it's 2/3 chance of winning, and then it's P, so it's 2/3 P.
Why did you say 1/4, 4/9? What are these? What is happening here?
Oh, I thought that the first two were played at home. I forgot that last part.
No, before that you said 1/4 also. That made no sense.
Oh yeah, I don't know what I was saying there because I didn't look at the probability of A winning at home.
Why? Why would you not look at this? Is like a coin toss that half probability every time.
Oh,
If you don't read the question carefully and the data in the question, then how do you expect to solve it? What's the probability of this happening?
Uh, P squared.
Wrong. What about the B here?
Oh, so 1/3 P squared.
What is going on? Why are you saying such things? You don't know what to do about probabilities and independent events and things like that. You have to multiply each probability.
Yeah, so then the probability of B winning is 1/3. Then the second day is, yeah, so 1/3 P squared.
Why did you say P square first?
Oh, I forgot the 1/3.
Why? Do you think this is a difficult problem that we are doing right now? Very difficult it is.
No.
Why are you forgetting important data? What's the probability of the third thing happening? I don't want
Uh,
an incorrect answer in the first attempt.
okay. So 2/3 times 1 minus P times P.
This is equal to 1/2. In the problem, they said that the probability of A winning the playoff is 1/2.
Yes.
You have to solve for P from this equation. Solve it and get the answer.
Okay. So then P would be like 4 plus or minus root 10 by 2.
What's the answer according to what the question says?
Um, so the question, it would be 1/2, so you remove that. Oh, so then it would be 14.
This is a super obvious question. The only
Hmm.
person who misses this question who is one who is not reading the question carefully.
Right.
What's the next question?
The next one is number 18.
There are exactly k positive integers b with 5 less than equal to b less than equal to 2024 such that the base b integer 2024 is divisible by 16 where 16 is in base 10. What is the sum of the digits of k? Watch that. What have you tried in this problem?
Mm, well, like it says divisible by 16, where 16 is in the base 10. So I was trying to think of like divisibility rules of 16, and it's like the last four digits have to be divisible, but then that doesn't really work. So since you don't have like a set number, kind of, I wasn't really sure what to do.
You have not even tried it. That means that doesn't really work. There is only one thing you can think of, the last four digits. There are so many other ways to think of how to check divisibility by 16. No? There are so many other things you can try in this problem.
I mean, divisibility by 16.
Did you think of the actual number that has been given and convert it to base B? What is the number in base 10 and check it with 16? What is the number in base 10? Did you try converting it?
Um, that number would be
Did you actually try converting it and then checking?
no.
Why not? You think that just because one thing didn't work, that's it. We give up down tools and that's it. How can you solve the problem if you have not even seen what this looks like in base 10? This is given, 16 is given in base 10. Obviously,
Yeah,
you need to have both the numbers in the same base first.
right.
You have not even tried converting this to base 10 and then seeing it, and then you are asking a question. Do it right now.
Okay. So you get uh 2b cubed plus 2b plus 4, and that number has to be divisible by 16. So then we could like divide that by 2, like take a 2 out. So then b cubed plus b plus 2 would have to be divisible by 8.
So now you cannot think about what to do here.
Yeah, I'm thinking. Mm, you could say that like So since it has to be divisible by 8, and if something is divisible by 8, it has to be an even number, and we already have a 2 there. So we know that b b cubed and b itself has to, wait, no, that's obvious. Okay, so never mind. Um,
There are many ways to think about it from here.
I guess you could just like trial and error it, but that wouldn't work because you don't know how many values of b there are. Um,
We have to check divisibility of this thing by 8. How many values do you need to actually check?
uh, oh, 8. Okay, so then we can start from like b is 0 wouldn't work. B1 wouldn't work. B2 wouldn't work. B3 would work because it's, yeah, B3 would work because it's 27 plus 5. Yeah, so 32. So B3 works. B4 B4 doesn't work. B5, mm, I don't think B5, if B is 5, it works. B6, 216 plus 8. Yeah, that works if B is 6. And then if B is 7, 343, 342. 152. Oh yeah, okay, so that works. So for so then 3, then 6, and then 7 were divisible. So for every 8, there's going to be 3. So you'd have to divide uh 2024 by 8 to get how many values, and then divide that by 3, like 3 of those. So oh, so it would be 3/8 times 2024. Um 3/8 times 2024. That's 759.
There are 759 possible numbers. Every cycle of 8 has 3 of them.
Yeah.
The only number that you have to worry about is this initial condition. In the first cycle, you cannot take 3.
Oh, right, right, right. So it's 758. So then the sum of that is 20.
This is not a difficult question. You have to just do a little bit of work. When
Right.
you have to write it into base 10. Without doing that, you cannot do anything.
Yes.
Once you get to this stage, you could have checked many things. You could have checked, okay, what are the possibilities of B? B could be even, B could be odd. Which type of number will fit? You could have said, let's say B is 2K. What happens to this? It is 8K cube plus 2K plus 2 is divisible by 8, which means again cancelling a 2, you can say 2K cube plus K plus 1 is divisible by 4. And now it is even smaller. It is divisibility by 4. So K, technically, you can see K can be anything 0, 1, 2, 3, mod 4.
Right.
And you will get a sense you cannot take K as 1 mod. You can actually 3 mod 4, or you can take it as anything mod 4 and just check whether this is working out to be divisible by 4 or not. That
Right.
that would give you the cases for b is equal to even numbers. Similarly, you can do the cases for odd numbers.
Yes.
If you don't want to do that, you can just do here checking 0. We have to make sure that this whole expression is 0 mod 8. We have to check what b can be, and it can be 3 numbers.
Right. Yeah.
The reason we are doing number theory, all of it, is because you should be able to think of these things. We are not doing it just for the heck of it, right?
Yeah.
It's not a difficult question. You have to attempt it a little bit. If you won't attempt anything, then nothing will happen.
Right.
What's the next problem?
The next one was problem 22.
What happened to 19, 20, 21?
I got those.
Okay. Let K be a kite formed by joining two right angle triangles with legs 1 and root 3 along a common hypotenuse. 8 copies of K are used to form the polygon shown below. What is the area of triangle ABC? Okay, triangle ABC. 8 copies of the kite are being used. First, we'll see what the kite looks like. The kite is basically set at two right angle triangles with legs 1 and root 3 along a common hypotenuse. So this is a right angle triangle, this is root 3, this is 1, the common hypotenuse is 2, and you
Yeah.
make another one like this, and this is my K figure. 8 of these Ks are used to make the figure shown in the question. So you have to visualize where are the kites in the question. So 8 of them are being used. 8 copies of K are used to form the polygon shown. Anyway, I don't think it's important to try to get all the kites there. What is important is we know right angle triangles. So we need to find out the length of the ABC in that. Area of triangle ABC we need to find out. So they have marked ABC. And they have this weird figure. If you have this kite, this situation, what is this right angle triangle's angles? So we can say easily that this angle will be how much?
Uh, 30.
This angle is 60 and this angle is 90. So
Yeah.
this is made up of two 30, 60, 90 triangles.
Yes.
In the figure given, there are many triangles. We have to see where the 30, 60, 90 triangles are, or if there
Mm,
are such triangles. Hmm. Okay, so eh, the figure is roughly, there is A, there is B, and there is C there, which is on top here. And in the figure, he has a right angle triangle, then another right angle triangle. So on A, he has a right angle triangle, then another right angle triangle. Then it goes down on the other side, and there are two right angle triangles. So we can see it is like this, and then like this, and then like this, and then like this to reach B. There are clearly four right angle triangles to go from A to B.
yes.
If the right angle triangles are similar to this kite's triangles, then we know that this is 2 and this is 1 and this is root 3.
Right.
And automatically all of these are root 3 and 1 and root 3. And this whole base A to B is clear.
Yeah.
It is 4 root 3. Similarly, now you have to figure out what happens on the other sides. Uh, One second, maybe I made a mistake. 4 root 3, is it 4 root 3? It is not clear how he is making a kite with these 8 copies of CK, he said. We have to
Yeah.
use that somehow. So each copy of K has two such triangles. So 8 copies of K means 16 right angle triangles are being used to make this figure.
Correct. Yeah.
16 such right angle triangles. So We can see. Okay, so actually this space is this space is the longest side. Yeah, I have made a mistake because 2 is the longest side. So um, okay, the figure. If you directly use right angle triangles like that, then you should get 4 root 3, but 4 root 3 doesn't seem to fit. Um, so in this kite figure, this was 1, this was root 3, this was 2. And if you drop a perpendicular, the height can be found out. What is the height of this triangle? You can say area of the triangle is half into 2 into height is
Yeah,
equal to also half into 1 into root 3.
right,
So height is root 3 over 2.
right, yeah.
Now, okay, so in the figure given in the question, this height, if it is root 3 over 2, this distance This is a different right angle triangle, and this distance is, this is root 3, this is root 3 over 2. So this much is, by Pythagoras theorem, you can say that it will be 3 minus 3 by 4. So 9 by 4 root of that. So 3 by 2. This distance is 3 by 2 and this distance is half.
Right, yeah.
So it is possible that the figure that we have, the right angle triangle that we can see at this edge, is not necessarily the overall right angle triangle. It is possible that this is just the right angle triangle inside it, this right angle triangle.
Right, yeah.
Hmm. But how would you know that for sure? Hmm. Not very clear what, how we can be sure of which triangle he means. Yeah, we'll skip this for now because right now I'm not getting what to do here because we are not sure what triangle he means.
Yeah. Okay.
If we are able to figure out how he has made the whole figure using kites, then only we can understand which triangle he means here. Because otherwise,
Right.
it feels
Yeah.
like it's an arbitrary thing what to do.
Yeah.
We are missing something, or the proof involves something else which we are not thinking of. So, um, I'll have to think about it. Let's move on to the next problem.
Okay. Uh, next one was 23.
Integers a, b, and c satisfy this equation. Integers a, b, and c satisfy equations. AB plus c is 100. BC plus a is 87. And CA plus B is 60. We are asking you to find out what is AB plus BC plus CA.
Yeah.
And some of the options given are 212, 247. Okay. Okay. Uh, the fact that they are integers should be useful for us. First of all, we can add all of them and say that AB plus BC plus CA plus A plus B plus C is
Yeah.
equal to 247, 160 plus 87, so 247.
Right.
So that immediately means that the answer has to be less than 247.
Right.
AB plus BC plus CA, unless A, B, and C are negative or something, right?
Right.
A, B, and C could be negative, then that does, looks like it is possible that they could be negative because some of the options are bigger than 247.
Right.
So, okay, if we combine couple of equations at a time, we should be able to take common factors. For example, if you combine first and second equation, you get AB plus C plus BC plus A is equal to 187. Here we can take common between here B common A plus C plus C plus A. So this is
Yeah.
C plus A into B plus 1 is 187.
Right.
187, think of the factorization of 187. It is going to be, it is not divisible by 7. 140, it is 9 is not working. 11, 110, it is divisible by 11. So 11 into 10, 17. So now we know that C plus A is either 11 and B plus 1 is 17 or the other way around.
Yes.
So this gives us cases because we get B is 16 and C plus A is 11, or B is 10 and C plus A is 17. We get two different solutions from these. Now we have to
Correct.
use the third equation and we can get CA plus B is 60 and use these cases there. CA will be 44 or CA will be 50, right?
Yes.
CA is 44 in this case, and then C plus A is 11.
Right.
This information can be used to find the possibilities of C and A.
Yeah.
44 is the product and 11 is the sum. So 4 and it's not going to work, I think, unless you take some negatives and all. So you can find out C minus A whole square is equal to C plus A whole square 121 minus 4 times 44. So clearly this is negative, so this doesn't work.
Right.
What am I doing here? How do I know it doesn't work? I took this perfect square C minus A whole square is C plus A whole square minus 4CA. It is
Yes.
coming out to be negative. It's impossible for integers.
Right.
Here C plus A was 17 and this is 50. So there you can also find now what are the possibilities. So, okay, we have not taken one of the cases. We have forgotten to do the plus minus case. It is possible for b plus 1 to be 17, or it could be minus 17 and minus 11 also.
Oh, right.
We have not done the plus minus. So what we should have done is c plus a into b plus 1 is 11 into 17. The cases are not just the plus cases.
Yes.
The reason we have to consider the negative cases is because we already got AB plus BC plus CA plus A plus B plus C is 247 or something. And so many options were higher than 247 for this,
Yeah,
which means that it is very likely that this might be negative.
correct.
If we realize that, then when we take factors here, we have to say C plus A is plus minus 11 and B plus 1 is plus minus 17, or C plus A is plus minus 17 and B plus 1 is plus minus 11.
Yeah,
And the way we have to do plus minus is if this is plus, this has to be plus. If this is negative, this has to be negative.
right.
And here itself, there are two cases. One case is C plus A is 11 and B is equal to 16. One case is C plus A is minus 11 and B is equal to minus 18.
Yeah,
Similarly, here also, once we know these two cases, there will be two cases here also. And once we know these two cases, we can look at the third equation that was given, which was CA plus B is 60. And put 16 in it, you get CA is equal to 44. We saw that it doesn't work when C plus A is 11 and CA is 44. Doesn't work.
right.
But now we have to try the other case here where B is minus 18. So CA is 18 plus 60, 78, and C plus A is minus 11.
Yeah,
78 is 13 6. So you can say 26 and 6. 13 6. Okay. 26 and 6. Okay, we don't have to do it like that. We can just say C minus A whole square is equal to C plus A whole square 121 minus 4CA. Yeah, again,
right.
you are getting negative. So this is not possible again. So we are not
Correct.
getting any solutions from here. We have to now try the other cases here. C plus A is 17 and B is 10, which means now CA plus B. So CA is going to be 60 minus 10, 50. This is
Yes.
one solution. From here, C minus A whole square is 289 minus 4 into 5200. So C minus A whole square is coming out to be 89. That is not a perfect square, so this won't work. The other
Right.
case is the other case now that is left for us is C plus A is minus 17 and B plus 1 is minus 11. So B is equal to minus 11 minus 1 minus 12. And now from the third equation, CA plus B is CA minus 12 is 60. So CA is 72. And now it clearly works because 8 and minus 9, minus 8 and minus 9
Yes.
will add up to minus 17 and will product will also be 72.
Correct.
Once you know C and A are minus 8 and minus 9, we can take cases of which one is which.
Yes.
There could be two cases. C could be this, A could be this. And using all the other equations now, we will be easily able to find B.
Yes. Correct.
So again, AB plus C, you can use that, or BC plus A and find B. And all this question took was a little bit of casework.
Right.
There is nothing hard about this question. We just added the equations once to realize, okay, what is the range of AB plus BC plus CA? It looked like it should be less than 247, but since the options were bigger, we realized that then that means that some of this could be negative.
Right.
After that, we just took the first two equations and got this factorization, and third equation along with this together is giving us so many cases which we are evaluating one by one.
Yes.
Again, not a difficult question at all, even though it is question number 23 or whatever, it is actually easy.
Correct.
What is the next question?
24.
A bee is moving in 3D space. A fair side six-faced die with faces labeled A plus, A minus, B plus, B minus, and C plus, C minus is rolled. Suppose the B occupies the point ABC. Okay. If the die shows A plus, then the B moves to the point A plus 1, B comma C. If the die shows A minus, moves to A minus 1, B comma C. Analogous moves are made with the other four outcomes. Suppose the B starts at 0, 0, 0, and the die is rolled four times. Okay. What is the probability that the B traverses four distinct edges of some unit cube? Okay. So some distinct edges of a unit cube. Four distinct edges. Wherever the B is, it will go in the direction, it will keep the other two coordinates constant and increase that coordinate by one or decrease it by one, depending on which phase comes up, A plus, A minus, B plus, B minus, C plus, C minus. So, okay. So if the B is starting out at 0, 0, 0, it's like you can make a move of in the three coordinates x, y, z, you can either go x plus minus 1, y, z, or you can go x, y plus minus 1, z, or you can go x, y, z plus minus 1, depending
Right.
on what turns up in the dice. If it was A plus or A minus, you'll do this. It was just B plus or B minus, you'll do this. The
Yeah.
probability of things turning up on the die are 1 by 6 for each possibility, right?
Yes.
All the faces are equally likely. Now, uh, so after the first step, since you are starting from 0, 0, 0, you can't really go to 0 minus 1, 0 and all, right? So mm, actually you can. So if you think of 3D space, this is X, Y, and Z. You're starting at the origin, but you can go in any direction plus minus one.
Yeah.
So 1, 1, 1. It is like a size 2 cube with center at the origin. You can go here and here, here and here, or here and here,
Yeah.
right? So
Right.
the size of each edge is 2.
Uh-huh.
So technically, you have a cube of volume 8, right?
Yes.
And we want to think of how can it move along the 4 edges of a unit cube. There are 8 unit cubes inside this,
Correct.
inside the whole possibility in 3D
Yeah.
space. So let's focus on one unit cube. One unit cube is the positive side unit cube.
Yeah.
This unit cube I am going to focus on, and I want my thing to travel along the 4 edges of this only.
Yeah.
That's what the problem is asking. What is the probability that it travels along the 4 edges of one unit cube?
Right.
Technically, there are 8 such unit cubes when you start from 0, 0, 0,
Yeah.
right?
Yes.
Okay, so first step, if you want to travel along here, the first step is can be done in 3 ways. You can go to 1, 0, 0, or 0, 1, 0, or 0,
Uh,
0, 1.
yeah.
First step, there are only 3 ways.
Right.
Uh, now, what is the question saying? You have to traverse 4 distinct edges of some unit cube. 4 distinct edges of some unit cube. So if you end up here, let's say, you can go, after that, you can go here, 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 or here, here, here. 2 ways. Okay, so 2 ways are there to go 4 edges once you have reached any one point. Oh no, 3 ways are. 1 second. If you have reached 1, 0, 0, from here, you can go like this, you can go like this, or you can go like this also. So there are 3 possibilities to cover 4 distinct edges. Um, Wait 1 second. After you have reached 1, 0, 0, how many ways are there to move? That's what you have to think. 1, 0, 0. Let's say we have reached. After that, you have 2 steps, 2 options in the first. You can either go here or you can go here, right? Okay, every time you have two options. It is obvious. After you have reached 100, the only possibilities for you are going up or going this way, right?
Yes.
After you reach go up, let's say, you have only two possibilities, going like this or going like this, right? After you reach here, you have two possibilities, going like this or going down. There's nothing else. So once
Yeah.
you have made the first choice, you have 2 into 2 into 2 ways to go around in any case. So basically 8 ways to go. The remaining 3 steps can be done in 8 ways after you have made the first move. And the first move could have been done in 3 ways, right?
Yes.
In this unit cube, you can start from 000. You can go here, you can go here, or you can go here. These are the 3 ways. But once you have reached this point, after that, every step has two ways.
Right.
Do you understand what I'm saying?
Yes.
Total number of ways is 24 ways.
Yes.
24 ways of moving around in that unit cube, right?
Right. Yeah.
Okay. Now, but there are total of 8 such cubes. So you should multiply this 24 with 8 because this was just one of 8 possible cubes.
Yeah.
So there will be 192 ways total of moving around in 3D space. Uh, the only thing you have to worry about is are we counting the same path twice in when we take a different cube here? Because we have counted 24 ways to move around in one single cube, but when we take another cube, because there are 8 such unit cubes, right?
Right.
There are 4 here above, 4 will be below, right?
Yeah.
The only thing that I'm worried about right now is out of this 192, it is possible that there are this shared path, right? Which is shared with the other one.
Yeah.
Then we are
Oh,
going to be counting the same path twice then.
yeah.
So right now 192 is a correct number, but it might have some points some paths that are coming twice when you share the unit cubes.
Yes, correct.
So we have to adjust for that somehow. So uh, how many shared faces are there? So okay, each cube has 6 faces and You have to think of how many faces are shared. So if you make a big cube and you are at the center and you have divided into two layers, what you have to imagine is how many faces are shared between the eight smaller cubes here. So the positive smaller cube shares what faces?
Uh,
So this face is not shared with anyone.
yeah.
But similarly, okay, this face is not shared because nothing will be above it.
Yeah.
But this space is also not shared.
Oh, yeah, because nothing's like beside. Okay.
So this space is also not shared like that. No, no, this space is shared because there could be a negative on this side.
Yeah.
Okay. So which other face? Okay, this space is not shared,
Yeah.
right? So three of them are not shared, three of them are shared, right?
Yes.
Similarly, okay, three of them are shared. If we had drawn the cube on the z-axis with a negative one, what would happen there? X and Y, this face is not shared, this face is not shared, and that face is not shared, right?
Yeah.
So basically, hmm, so far we have three shared faces for that one also. This counting part is a little annoying. Hmm. Because if we can find out the exact count, 192 is our estimate. If you can remove the counting of the ones that are shared and we are counting double, that's
Yeah.
it. Then we can find the probability because uh, randomly starting from 0, 0, 0, there are, we can count the total number of steps that are possible.
Right.
You can go in any three directions. You can go plus minus one. So six ways to do anything. And six ways to do either step, any step. So technically
Yeah.
you have 6 power 4 in the denominator. The only
Yes.
issue is that I'm getting 192 by 6 power 4, but I don't know, like it will be wrong because there will be some common paths that I have counted. We have to adjust for that, which is what is annoying.
Yes.
The common paths is the annoying bit that we have to think of how to remove. Uh, Maybe there is another way to figure out how to not get these common paths. Yeah, I have to think about it to how to adjust for this stuff. But if you get the answer like this, you can sort of estimate from the options which one is close to this.
Right. Yeah.
192 and 6 into 6 into 6 into 6. So if we even if we know that is wrong, at least it is in the ballpark, we can see which option is closer, right? This is
Yes.
96 and this is 3. This is 32. And we get 32 by 216, which is 16 by 108. And I'm getting like 8 by 54.
So it's 7 by 54.
8 by 54 is my rough thing. No, that is roughly close to 7 by 54 or Is there anything else which is close? Other ones are 15 by 54, 9 by, okay, it could be 9 by 54 also,
Yeah, so
which is
that'd be
B
one.
or C. But
Yeah,
9 by 54 is higher, so it cannot be higher than this
correct. So it's
because
B.
we have to reduce, right?
Yeah.
So even if my answer is not coming exactly right now, I know that is not correct, but I can still get the options because it's a multi-correct question. It's a multiple
Yeah,
choice.
correct.
But like we have to think of how to get the answer properly. So, right now, I'm not able to figure out how to reduce it from 192. Anyway, we'll think about it. This
Okay.
problem, and which number was it? The other one, 22.
This was 24.
The other one, the kite one, was which number?
Oh, the kite was 22. Yeah.
Okay. Usually, like, see, if there are only two, three problems that are like that, it's fine. It should not be
Yeah.
more than that. You should be able
Okay.
to solve everything else in the paper.
Okay.
It is possible that two or three problems could be difficult and you couldn't get it. But
Mm-hmm.
right now, you're not doing the problems in a time limit. So you are right now trying to see that how many you can actually do. So it's not
Yeah.
good to just give up on them.
Okay.
When you are attempting at home, you need to attempt everything with all your power of all the techniques you could use. There are so many other questions that you could have done, but you have asked.
Right.
Question number 15 was 17 or whatever. Some of the questions you've asked today are not worth asking.
Right.
At home, you're not doing in a time setting right now. If you're doing in a time setting, there will be more complications. Right now,
Yeah.
all we are trying to see is how many of the tough ones can we actually do. It
Right.
is okay to be able to do 7 or 8 out of these 10, but it should not be more than two, three questions that you are unable to do.
Okay. Yeah.
So try it harder and don't give up on the questions so quickly.
Yes.
Some questions will be like this, which will be too difficult or annoying or whatever, but that happens in any exam, that's fine. But right now, our focus is on figuring out, can we increase our ability? Can we make sure that we have the confidence that actually, given enough time, I should be able to answer 21, 22 out of 25?
Yeah.
Only if you solve it yourself and are able to do this multiple times can you feel that confidence that, okay, my ability is, I should be able to answer 21 out of 25 or 22 out of 25. Now it's all about making sure that in the exam I do it fast.
Right.
That is its own set of challenges. Like if you have to do the exam in 75 minutes, it's not like very easy to do it.
Yeah.
But that challenge comes only after you have the confidence that you can do questions.
Right. Correct.
We can work on the speed and accuracy and all only after we are sure that you can actually do 22 out of 25 yourself or 20 out of 25 yourself.
Right.
So when we are right now at this stage and we are trying to figure out, can we do 20 out of 25, 21 out of 25, you need to try every possible method. You
Yes.
can't just be like, I didn't get it. I just thought of one thing and left it. Do you
Right.
understand what I'm saying?
Yes.
Whatever you know, maths, every possible method you need to try.
Yes. Okay.
And how much time are you spending doing this every day?
Mm, I don't do it every day. I do it like some days. But when I do it, I usually do it for like uh an hour or two. But I do it like
If you
30
have to excel at this, it needs to be every day.
Okay, yeah.
If you want to achieve something, it needs to be every day. People who go ahead and do great things in AMCs and AIMEs and so on are working on it every day.
Right.
It cannot be a casual hobby. It's not a hobby. If you want to improve, you have to work on contest math every day.
Every day, right? Yes.
No matter what is the school thing, unless it's an exam the next day, there is no good excuse to not do math.
Yes. Okay.
If there is an exam the next day, that's the only possible excuse of not doing it.
Okay.
No matter
Yes.
what is going on in school, you have to find 1 hour or more. The
Yes.
amount
Okay.
you find is up to your motivation and up to your ambition. If you want
Mm-hmm.
to do really well, you need to find more time. There is
Okay.
really no other way to improve, no matter what teachers you get or how much somebody else wants you to improve or your parents want you to improve. There is really no other way. The
You're right.
only way to improve is working on it every day.
Yes.
And if you see people who have done really well, I can send you uh, a girl who did really well in math Olympiads, starting from sixth grade, seventh grade. She had wrote up her whole experience on AOP's website.
Uh-huh.
She used to work 3 hours every day for 2, 3, 4 years. That's the consistency that is required. From seventh grade, eighth grade, when she started appearing in these AMCs, from that time onwards, she used to work 3 hours every day. That was her thing.
Right. Yeah.
If you work 3 hours every day on math and especially contest maths and problem solving and learning, even if you
Yeah.
do it for 1 year or 6 months, you will
Mm-hmm.
be a different person.
Right.
But if you do it like a hobby, like a casual chill thing, like once today, 1 hour, 2 days later, 1 hour, then nothing will improve.
Mm-hmm.
Nobody is
Right.
asking you to do 3 hours every day, but you need to do something every day.
Okay.
You
Yeah.
need to make it a habit that I have to
Yes.
do 5 problems or 3 problems or 4 problems. Today I will try. Today, every day I have to do it and I will try.
Okay. Yes.
We don't want everyone cannot be the same person, so you don't have to copy this person, but there has to be some commitment and some effort which distinguishes you from your peers.
Right.
If there
Yes.
is nothing special about you in your prep, there will be nothing special about you in your results.
Right.
So if you want to actually do very well on it, you need to change things and work on it every day. Even if it is for 1 hour or half an hour or sometimes more, it has to be consistent.
Mm-hmm. Yeah.
Find the other, start doing the other papers. The next paper would be 2024B. Again, in the papers, work on the 15 to 25 right now.
Correct. Yeah.
If
Mm-hmm.
the paper is over, you need to go to the previous year's papers that you haven't done, maybe 2020 or 2019 or whatever.
Okay.
There
Yeah.
are enough papers on AOP's website. You need to just keep working on the last 10 questions.
Yes. Okay.
We will be doing this exercise for maybe 1 more month. Like,
One more. Okay. Yeah.
s- so once we have seen all the papers from 2015 onwards, let's say, once we have discussed the 2015 onwards papers, again the focus will shift and the 2 classes per week, one class will remain number theory for some time, but the other class will become something else. We'll work on maybe some of the specialized topics like probability. We'll work on some topics that we are seeing are difficult or some topics where we are struggling or anything like that.
Okay. Yeah.
We will make a list of those topics. These topics are, it doesn't have to be a subject, like, doesn't have to be just geometry or just algebra or number theory, but we'll
Yeah.
pick and choose the topics accordingly and do it like that.
Okay. Yes.
But the point is that we need to get that data by doing all of these papers to understand, okay, which topics we need to work on.
Yes. I understand.
That's why we are doing these papers, to understand what is the need.
Yes.
So focus on it and make sure that your effort is a little more consistent.
Yes, I understand.
Okay, fine. We'll continue with number theory in the next class.
Mm-hmm. Okay. Thank
Mm,
you.
mm.
Bye.
Bye.